So this problem that we have here, we have the sorter is used to test the response of an airplane during the crash. So the airplane is held by a cord, and actually is held also by a cord over here, right? To have it at rest at this position, and is released. That cord is cut, and the airplane goes in a circular trajectory till it crashes. So, and they want to measure the speed for an angle right here when the airplane is over here, theta equals 15 degrees, right before it crashes. And they also want to find the tension of the cord for that position. So in this case, in this problem, we are relating velocity that we want to find with position and displacement, right? And force, because we have the weight and the tension. It's always very important to do the free body diagram. So if we do the free body diagram for a generic position, right? So we have our plane right here. And then we have the weight. And then we have the tension. And as you see, those are the only forces that we have in our system. And as you see, there is no displacement or the plane in the direction of the cord, so this tension does not do any work. And the only force that we have is a conservative force, which is the weight, right? The force. If we know that this is theta, right? Okay, so if we want to use the principle of work and energy, we know that the work done by non-conservative forces is equals to T1 V1. So it's kinetic energy plus potential energy minus kinetic energy, potential energy in the position 1. We just said that there isn't any non-conservative forces because the tension doesn't do any work. So we actually here have conservation of energy. T2 plus V2 is equals to T1 plus V1. Being 1, this position over here, and being 2, this position over here. As we see, we have position 1, we have rest. Therefore, we can already say that this is equals to 0 because due to rest. And to find out the potential energy, we have to put a datum. So since those two positions, we have angles involved, I'm going to put my datum over here. So we will have a height 1 and height 2. To calculate my potential energy, I have two distances, right? Where is the airplane located at position 1 and where is the airplane located at position 2. So let's calculate we already know that kinetic energy is equals 0. Potential energy at my position 1, the only force that I have is the weight. So it will be, since I put my datum over here, I have negative potential energy, right? It's below my datum, which is mass, gravity, H1. Being H1, we can calculate it because we have the distance or the length of the cord, and we have the angle in position 1, which is 60 degrees. So we have negative, and we have also the mass of the airplane, so, which is 8 times 10 to the 3 to convert it into kilograms. So it will be 8,000, right, kilograms times gravity times H1, we said is 20. And we said it's cosine of 60. And cosine of 60, we know that is 1/2. Then we have T2 will be equals to 1/2 mass times velocity, which is actually what we want to find. And then V2 is equals to negative as well, H2, which is equals to negative 800. 9.81, 20 cosine of 15. So if we put all this together, as you see, every single element will have the mass, so the mass will cancel out. At the end, I have T2 plus V2 will be velocity squared So if I write the mass, I will show you that it just cancels out. So I'm not going to write the mass again, which is, so as you see, the mass cancels out everywhere. And we have this solved for velocity. It will be equals to, let me write it here, 2 times 9.81, 20 cosine of 15 minus cosine of 16, right? Okay, so the velocity is equals, when you solve this expression, you have that the velocity is equals to 13.2 meters over second. So we were able to find the speed when the airplane is about to crash, and now we have to find the tension. To find the tension, we already have the free body diagram. We have to do our kinetic diagram. Let's do it right here. My kinetic diagram will be the airplane. And since I have a curvilinear motion, I will have a tangent acceleration and a normal acceleration. Since what I want to find is the tension, I will add forces in my normal acceleration, which is this one right here. And since the normal acceleration, we know that is the velocity squared over radius of curvature, and the velocity is the one we just found. We see that to find tension of the cord, we add forces in the normal direction, and that will be equals to tension minus weight cosine of theta equals to mass times normal acceleration. So the tension will be equals to the weight cosine of 15, right? Because we are in the second position, plus mass times velocity squared over radius of curvature, and the radius of curvature is 20. And the weight is mass times gravity. So weight is mass times gravity. So if I substitute the weight, I will write 100 times 9.81 cosine of 50 plus 8,013.2. So solve, and if you calculate that value, that gives you equals to since it's a very big value, we can actually write that in kilonewtons. Since the mass was given in meganewtons, we can actually take 3 significant figures and we can write something like that. So that will be the tension that the cable has in position 2, where the angle is 15 degrees.